Good morning, class. It is Friday morning, May the 11th, 2018, and I wanted to make another short video before I get into chapter 2, just to go over some statistical concepts, talk about some symbolism that we're going to be seeing, and I'll probably give you another short homework assignment based on what I'm covering today. The more homework we get, the better it's going to be for your grade. I don't think it's going to be too difficult for you to do. So let's get right into it. I talked about population, I talked about sampling in chapter 1. So I want to go over some of the symbolism. So the uppercase N, so big N we'll call it. That's going to represent all the people in a population, or all the numbers representative to a population. N is going to be our the number of participants or the number of points in a data set. So if I have a data set with 5 scores, N would equal 5. Now I'm going to be talking about a sample, part of a population. I'm going to be looking at lowercase n. So lowercase n is going to represent a sample. So all the participants or all the data points in a sample is going to be lowercase n. So now what I want to do is I want to talk about variability or spread. What is the variability within a data set or a group of numbers? Well, we're talking about variance. So if I'm looking at a population variance, I'm going to use a symbol called sigma. And it's a Greek symbol, and it's going to be the lowercase sigma, and it's going to be sigma squared. And if I'm looking for sample data, so sample data is going to be uppercase squared. Now I want to talk about standard deviation. And a standard deviation is going to be the standard distance from the average. So that is going to be sigma for a population, and it's going to be the uppercase S for a sample. Now I mentioned the word average. Now with a population, the average is going to use the Greek letter mu, not pew, but mu. And it's going to look like that. It's going to look like an M or a U, however you kind of perceive that to be. Now with a sample set of data, we're going to use the Greek or the Roman numeral X. And we're going to put a bar over that, and that's going to be our sample average. So we'll start with all of this first. Now what I want to show you is how we summarize things. We're going to use sigma again, but we're going to use the uppercase sigma, and it's going to look like kind of like an E. So this is the Greek symbol for adding. So anytime you see this, you're going to be required to do some addition or summarize data. So remember this: population, sample. Now what I'm going to do, I have a Word document that has a lot of symbols on it. I will include that with this video. I'll give you that sheet. So it'll kind of break down the symbols, and it'll give you them in one piece of paper so you don't have to look all through the book. Now, what I want to do is I want to talk about how we can use these numbers. I talked about variance and standard deviation. I'm going to show you how to hand calculate this with a very small data set. So we're going to use a formula, and it's going to be the formula for finding the variance and the standard deviation. And I'm going to go ahead and use this existing sigma, because we're going to need to utilize that. So I'm going to use a symbol X, and it's going to represent a number in a data set. So if I have a data set from, let's start here, 1, 2, 3, 4, and 5, that's my data set. I want to find the standard deviation for this particular data set. So what I'm going to do is, the first thing I got to do is read my formula. So I've got X, and I want to subtract the average. And this is a population. So all my symbols are going to be population symbols. So if I do this particular formula, I will find the variance. But I want to find the standard deviation. So if I'm looking at population data here, I know that this is the standard deviation, lowercase sigma. I want to have to square that. So if I square my standard deviation, I will get my variance. So if I get my variance first, in order to get the standard deviation, I'll have to take the square root of the variance. And that's how I'm going to find that. So the relationship between the variance and the standard deviation is I square my variance to, I square my standard deviation to get variance, and I take the square root of my variance to get my standard deviation. And I'll show you how this works. So with my data set here, I'm going to find mu first. And how I do that is another little formula. I'll take sigma, and I'll add up all my x's and divide by n. So that will give me my mu. So mu is equal to adding all my x's up and dividing by n. So let's do that. I've got 1, 2, 3, 4, and 5. When I add that up, it will equal 15. Now, I want to be able to divide that by 1, 2, 3, 4, 5, and that will give me a value that's equal to 3. So mu, let's do it right here, mu is equal to 3. That's my average. So now I've got my formula, I've got everything I need in order to work my formula. So I'm going to work inside my parentheses first. I'm going to subtract the average from all my x's. So I've got 1 minus 3, 2 minus 3, 3 minus 3, 4 minus 3, 5 minus 3. So what I want to be able to do now is I'm still commanded to add. So when I subtract 1 minus 3, it should give me a value of -2. When I subtract 2 from 3, it should give me a value of -1. 3 from 3 is 0. 4 from 3 is going to be 1, and of course 2. I'm going to add these up because I'm commanded to add, and I should get a value of 0. If I get a value of 0 when I add these scores, these are called deviation scores. They deviate from the average. So 2 deviates from the average 1. 1 deviates from the average 2. 4 deviates from the average 1. And 5 deviates from the average 2. So when I add all those up, I've got negative scores and I've got positive scores. And when I add them up, it equals 0. Our deviation scores always equal 0. Now, I've got an exponent, so I'm going to square these babies. So when I square -2, if I square a number, if I square a negative number, it turns it into a positive number. So when I square -2, it'll turn into 4. I square -1, it turns into 1. 0 squared is 0. 1 squared is 1, and 2 squared is 4. So when I add these up, because it's still commanding me to add, I'm going to get a value of 10. Now I have just figured out how to calculate my numerator. It is 10. Now I know that n is the number of values that I have, or the number of data points. So I've got 1, 2, 3, 4, and 5. 5 is n. So when I